In this video, we are going to solve one of the most common sliding window interview problems. The problem is called maximum sum sub array of size k. So, as you guys already know, that I made a concept of sliding window pattern and also types of sliding window patterns in my previous videos. Please do watch it and then start with the program, that is maximum sum subarray of size k. So I will start by creating simple Java class, that is public class maximum sum subarray. This will contain both our logic and the main method to test. Now let me add a main method. This main method is just for testing our logic with a sample input. Let me just take the sample input, that is array of numbers. Is array of numbers. Let's just take 2, 1, 5, 1, 3. Let's take size of the array is equal to 3. So this is our input array and k represents the size of the sub array. Let me create the method that actually solves the problem. So let me create the method. For example, find a maximum sum method. Since it returns uh, integer, I added return type as int, and since the input we are giving as input array as the integers, so I'm taking as the input array as the integer, and also we are giving the size of the sub array integer. I have taken this, and first we need to initialize the variables. Int so Windows sum is equal to 0. Max sum is equal to 0. So Windows sum will store the sum of the current window, and maximum sum will store the maximum sum we have seen so far. So let me take a look here. We'll loop through the array once, and we'll loop through the array once, and as we move forward, we add the current element to the Windows sum. Let me take from here. Windows sum, Windows sum. Greater than or equal to k minus 1. So this condition helps us check whether our window has reached size k. Until index k minus 1, we are just building the first window. So max sum is equal to math dot max sum minus window sum. Once the window size is k, we compare the current sum with the maximum sum so far. So we in this tab, like we remove the element that is going out of the window, so the window can slide forward. Then max sum here. So as we all of us know, for checking all these possible windows, we return the maximum sum. So in order to check that, let me give system dot print ln hyphen, sorry, comma. Okay. So in this method, so here basically as I explained the concept and in my previous videos, so the window size is k. Let's just take like 3. If it is 3, 215. 215, sum of 215, 2 comma 1 comma 5 is equal to 8. And sum of 1 comma 5 comma 1 is equal to 7. And sum of 5 comma 1 comma 3 is equal to 9. And sum of 1 comma 3 comma 2 is equal to 6. So out of this, we should get maximum as 9. When we run this program, we should get maximum as 9. So this is the window size, that is 3. For each window size, we are calculating the sum. After calculating the sum, we are checking which one is the maximum, and we are returning that element. So here, this is the nums array, integer array, that and the window size we are giving to this method. And this static main method is the static method. So only those static methods are called. So here we return it as the static, and we passed nums array and the window size. So, and we took the local variables as the window sum, that is 0, and the maximum sum 0. For I is equal to 0, and if the nums dot length, that is the total length of this array, which is 6. So if I is less than 6, we'll go inside and we'll add the nums first element, first element size. That is, first element, first index. So I is 0. Nums of 0 is 2. Nums of 0 is 2. We add to the window sum. Previously it was 0. When we add 2 to the window sum, it becomes 2. Okay. And we'll check the condition. 0 greater than or is equal to k minus 1. We know k is 3. 3 minus 1, 2. 0 greater than or is equal to 2. So the condition is not satisfied here. Again, it loops through here and I becomes 1. When I becomes 1, window sum becomes 2 plus 1, it becomes 3. So 2 plus 1, it becomes 3. So here I is 1. 1 greater than or is equal to 2? No. So again it loops through and I becomes 2. Now window sum becomes 2 plus 1 plus 5. That is 8. Right? So I is 2. 2 greater than or is equal to 2. So condition becomes true. Now we'll check the maximum. Window sum is 215. That is 8. Window sum is 8 and maximum is 0 because we initialized the maximum with 0. Out of these two, which is the highest one? Window sum. Window sum is the highest one. 0 and the 8. So we'll store that in the maximum sum, that is 8. And window sum, now we need to minus one element. Now we are removing this element, and then we are moving to 151. As I shown here, now we are moving to 151. We store the maximum as 8 and nums I is 2 and 2 minus and k is 3. We know the window size 3. 3 minus 1, 3 minus 1, 2. 2 minus 2, 0. So overall nums of this 0. So nums of 0 is 2, right? In the window sum, we excluded the 2. That is, when we excluded the 2, now window sum becomes 1 plus 5, that is 6. Right? After this, again, I becomes plus plus, that is 3. I becomes 3. So when I becomes 3, I3 is, nums of 3 is 1. Now what window sum becomes? 1 plus 5 plus 1. So that is 6, 7. It becomes 7. Once it becomes 7, I is 3, right? 3 greater than or is equal to k. K is 3. 3 minus 1, 2. 3 greater than or is equal to 2. Again the condition satisfies. Now it comes inside and the mat.max. This is the function which gives maximum value of out of these two values. So we know now the window sum is 1 plus 6 plus 1 plus 5 plus 1, that is 7. And previously stored value of maximum is 8. 8, this is 8 and this is 7. Maximum out of this is still 8. Again, maximum is equal to 8. Now, what we will do? Here we know I as 3. 3 minus and k minus 1, that is 2. 3 minus 1, 2. 3 minus 2, that is 1. Now we remove this element 1. Now we need to do the summation of 5, 1, 3. So now the window sum So now we remove this element. Now the window sum is 5 plus 1, that is 6. Again, the I becomes 3 plus 1, that is 4. 4 less than nums dot length 6. So it satisfies this condition and it goes inside the loop. And nums of 4. Nums of 4 is 3. So now the window sum becomes 5 plus 1 plus 3, that is 9. And 4 greater than or is equal to 2. Why? Because 3 minus 1, 2. 4 greater than or equal to 2. Condition satisfies here. And here, previously maximum sum stored is 8. Now the window sum is 9. Maximum out of this is 9. So maximum sum is equal to 9. Again, window sum becomes, again similarly, we remove this element. Now we calculate for 1, 3, 2 element. Previously it is 4. Now I becomes 5. 5 less than or is equal to 6. 6 and nums of 6 is 2. 2 means like 1 plus 3 plus 2. That is 6 in the window sum. Now window sum is equal to 6. And here 5 greater than or equal to 2. It satisfies the condition. And the sum is 9. 9 maximum sum we previously stored 9. And window sum is 6. Maximum out of this is 9. So maximum sum now is equal to 9. So when the maximum sum is equal to 9, let me write it here. Now the window sum is equal to, now we remove this element, that is I. I is 5. 5 minus 3 minus 1, 2. 5 minus 2, 3. We remove this element. Window sum. From the window sum, we remove this element. Now we have only the sum 3 plus 2, that is 5. And now I becomes 6. 6 less than or equal to less than 6. So the condition not satisfies and it comes out of the loop. After coming out of the loop, the maximum sum what we have is 9. So this function returns 9 and it should print 9 here because out of all these 4, the maximum sum we have is 9. So let me run this and check. So here, if you observe, the output is 9, which comes from the subarray, 5, 1, 3. So this confirms that our sliding window logic is working correctly. The time complexity of this solution is big O of n, because we traverse the array only once. That's the reason the time complexity of the solution is big O of n. So this is how sliding window technique helps us avoid repeated work. In the next video, we'll solve a variable sliding window problem, which is also very common in interviews.